All right, so we can also use identities to help us solve equations, and these next three examples are just examples of doing that. So let's take a look at the first example here. We have the sine of theta is equal to the square root of 3 times the cosine of theta. All right. Now, what I can do is just divide both sides by cosine. So, and then I can also divide both sides by 3. So this equation is equivalent to the sine of theta over the cosine of theta. And then I'm going to also divide by 3, both sides by 3, so square root 3 over 3. Now, that might look familiar to you. That's equal to 1 over the square root of 3, which is also equal to 1/2 over the square root 3 over 2. Okay, and you might recognize those as being sine and cosine values for a certain angle. So what is that angle? If you look at your unit circle, if I look at my unit circle, which angles have essentially a tangent, right? This is essentially a tangent. Tangent of theta is equal to 1 over the square root of 3. But what angles have sine of 1/2 and cosine of square root 3 over 2? So, I can, or it could be negative, right? Negative 1/2 and negative square root 3 over 2, right? Both of those would give us a positive 1 over the square root of 3. So, all right, well, I know that one of those angles is pi over 6. Pi over 6. Pi over 6 has a cosine of square root 3 over 2 and a sine of 1/2. All right. Now, the other one is over here that has that same tangent value, because this would be the case where we have a negative cosine, or negative sine and negative cosine. And this angle over here is 7 pi over 6. Okay. And so the cosine is a negative square root 3 over 2, and the sine is a negative 1/2. So it also has a tangent value of 1 over the square root of 3. So my two theta values are pi over 6 and 7 pi over 6. All right, I'll meet you in the next video.